Our native fungi serve a number of purposes, but one of the most important is to decay living, dead and dying organic material. And that of course includes wood. We need to always keep in mind that species we find inhabiting, for example, a Scottish coniferous forest may be very different to those that pick their choice of restaurants on a lowland riverbank. Many crust and bracket species aren't fussy about their choice of food. Others are more specific and selective in their requirements. Within the range of crusts and brackets, the sheer extent of form and shape, colour and texture can be both daunting and fascinating. Sometimes it's quite magical. They can be small and delicate. They can be decidedly weird. They can be definitely large and eye-catching. They can also be very beautiful. Some species can play a key role in shaping, sculpting, altering the features of our natural landscape. This is common birch bracket. Crusts and brackets isn't a proper scientific grouping. It's actually a loose collection of fungi that grow on plant remains and on wood, either as crusts or skins that are tightly applied, or as plates, little delicate plates or great big dinner plates like this. They used at one time all to be put into what is called the aphilophorales, which roughly means fungi without gills. So it excluded things like oyster caps, which grow on wood and which do have gills. We're going to include mostly basidiomycete fungi. We've got one jelly fungus to go in, which looks a bit like a bracket, and we've got one ascomycete that looks a bit like a bracket. But even within the main range of crusts and brackets, there is quite a confusing extent of structures and colours and sizes. Let's dispose of the oddities first. It looks like a typical crust, but it's actually an ascomycete, Kretschmaria duster. It appears in two forms: in spring as this pale grey conidial stage, which then changes into a more crusty black and longer lasting perithecial stage. It causes a damaging rot in beech trees. In contrast, this looks in some ways like a little rather rubbery bracket, but it's a jelly fungus related to Jusia. Reminiscent of gut mesentery, it's called Auricularia mesenterica. Let's just consider for a moment why some fungi grow as skins closely applied and others grow as brackets. If you are closely applied as a skin, basically your spores have got to be able to drop under gravity, and that means that the only place you can effectively grow is underneath a piece of log or branch or whatever, and that's not particularly efficient, particularly if that piece of wood is lying on the ground, because the only place your spores can go is straight into the ground. So ideally, you want to stick yourself out like a little shelf, which we know as a bracket. And you can see some of them here. And what it means is that there is free space underneath those, whether this is stuck up on a tree or whether it's lying on the ground, for the spores when they're ripe to drop and then blow away in the air currents. Featureless jobs like this are the simplest and often the most difficult to identify. Crusts tend to live underneath, so to see them generally you have to turn wood over. Some are more recognisable than others, like Coniophora putiana, with a brown hymenium and white fringed margin. There are some useful tips to pick up. Stereum sanguinolentum on conifer wood appears to bleed if you scratch it. But the resupinate mode of the common Stereum hirsutum doesn't. These forms aren't very efficient at shedding their spores, and the aim is to form a shelf, which is what happens here in Stereum subtomentosum. Then your fruiting surface extends to the sides and top of a branch or log. This, in case you don't recognise it, is Trametes versicolor, turkey tail, one of the commonest small brackets. The fertile hymeneum of the very simple forms, like the stereums, is never elaborated into pores or spines. The spores are produced on a bald surface. But that seems not to be an impediment. Hymenocete rubiginosum has a bald hymeneum, but it's common, and here it's successfully spreading its lovely coppery brackets up the vertical surface of an old plank. Once you can develop into a shelf, opportunities grow, and one of them is the size you can achieve. The bigger you are, the more spores you can produce. The tougher, the more resistant you become. Ganoderma is perennial. Each visible layer represents a past season's growth. I've said that different species are found in different kinds of woodlands, but one of the best places to start getting the hang of crusts and brackets is in a lowland beechwood. The season isn't generally restricted. From midsummer onwards you'll find fungi fruiting. Beech, living or dead, seems to be the kind of mecca for lignicolous or wood-favouring fungi. It's not too difficult to discover a range of species on one foreland giant. From August onwards, this remarkable wreck is playing host to an array of crusts and brackets in a multitude of colours and textures, all serving the same function to invade the dead wood, digest it and rot it down. Trametes versicolor is a predictable occupant, and this array is showing its white porous undersurface nicely. On a big trunk, the mycelium running under the bark can extend for a metre or more. Notice the change from crust to bracket as the fruit bodies venture round the girth. Further on, we find a whole platoon of the mature caps of Trametes gibosa. One of the characteristics of this species is that its lumpy upper surface regularly attracts a dense growth of green alga. One of the things I find truly fascinating about fungi is how adaptable they are, how they've evolved over a period of time to cope with different situations. If you look down here, you'll see there's this massive array of Ganoderma brackets which grew after this tree had fallen over in a gale sometime 2 or 3 years ago. And they are lined up in line with the trunk that's now horizontal. And the importance here is that whether it's pores, tubes, whether it's gills, they've all got to be lined up vertically so that the spores can drop in the free space under gravity. So they're what are called geotropic. If you look, however, to the right-hand end here, just where the old root buttress was, there is a Ganoderma which is at right angles to the other ones, and that quite clearly grew on this trunk before it fell over. So it was in an upright position, and that bracket there is relevant to its rotation when it was standing upright. Ganoderma australe and Ganoderma applanatum can be tricky to tell apart without a microscope, but you can find them at any time of year, and they make just the most wonderful sculptures. Much the same is true of Phamis fomentarius, whose appearance can be deceptive if it's growing on a flat horizontal surface. Here, it persists on the trunk of a long dead birch, and its remnants have a more familiar appearance. You can see why it's called the hoof bracket. When you're searching for brackets on woody debris, one important rule is to look at the underneath of a fruit body. That's where critical diagnostic features may lie. From above, it's possible to confuse Trametes jubosa, but from below, its slotted pores are a useful indicator. The view from the top can lead you down false paths. At a quick glance, this could be Trametes versicolor, but it isn't.
Here's a good example of how you can't necessarily take these things at face value. Two little brackets on this stump, both of which on the face of it, from the top, look pretty similar. That is until you turn them over. You see, when you look at the underneath, you see that this one, Trametes versicolor, the turkey tail, has pores that are cream coloured, and this one, which is Burkhandra adusta, we've just found on the stump, has pores that are dove grey.
Colours are often significant in identification. You need to keep an eye on spore colour. Ganodermas, for example, produce millions of brown spores that can coat nearby surfaces. The old Phelinus group of brackets have brown pores, but their spores are colourless. Colour is important in different ways. This may not produce distinctively coloured spores, but it's another of those curious stereums that goes blood red if you scratch it. This one is Stereum rugosum on beech. Any beginner will quickly learn to recognise this, the blushing bracket Didaleopsis confragosa. What is there to remember it by? Well, it has slotted pores like some others, but they blush, turning a sort of dusky red when you press or rub them with your finger. Eventually, the whole bracket can turn an eye-catching deep purplish colour. Some species reveal other curious physical features that can leave you wondering why, what for. Mensillaria radiata is most commonly found on alder, though it can grow on birch. It extends in long tiers or ledges of rather stubby gold or russety brackets down an old or weakened trunk.
Let me show you something interesting about this stuff. This is a bit of kind of woodland street cred, if you like, that will help you on identification. Some bracket fungi, when you turn them over and look at the pores in the light, they change colour, like almost iridescent. There's a strange refraction of the light. Let's get one of these off. Now, I don't know whether you can see this on the camera, but if I just tweak this gently, backwards and forwards in the light, you should be able to see maybe that the pores are changing colour. They're going from very pale to much darker.
The range of shape, size and texture in crusts and brackets will make better sense by understanding a bit more about their building blocks, how they're put together anatomically, because it can be quite complex. So let's take a few minutes out from the woods and fields.
Throughout the fungal kingdom, there are three basic types of hyphal structure. There are in fact more, but from our point of view, let's stick to three basic types. And they all perform different functions. So let's go through them one by one. All fungi, doesn't matter whether they're mushrooms, toadstools, jelly fungi, puffballs, brackets, crusts, all have generative hyphae. They're the sort of basic blueprint from which other types of hyphae are developed. And their characteristics are, first of all, that they are living. There are food and water channels going through them, and they are essentially alive. Thin-walled, but they can develop thickening of the walls while they're still alive. Other features, they rarely branch. Doesn't mean to say they don't branch, but they rarely branch. They have particular features, including cross walls, which we've got one there and another one there. And those are simple cross walls. They're permeable. They're like sieves running across from one section to another. And then those cross walls can, in some species, not all, be elaborated into these strange things called clamp connections. Nobody really knows what clamp connections do or are for, but they either form a little sort of flange coming halfway round the septum or cross wall, or they come right round and connect like a little sort of bent finger. Well, that's the first one, and all fungi have generative hyphae. So let's move on to the next one. Here we've got a mixture of two. We've got simple generative hyphae. There's one running down here. There is part of one running here. I'll explain why part of one in a minute. You'll see that this one has got a slightly thickened wall, but it's still got a decent cavity or lumen for food and water to pass through. However, out of these generative hyphae can develop what are called skeletal hyphae. This is the second type, of which this one here is characteristic. And there's another one running here. And you notice immediately that one of the fundamental differences is that the walls become extremely thick and the lumen or the cavity becomes very small or virtually non-existent. These hyphae are no longer living, they're dead, and the cell walls become impregnated with what's called fungal chitin, which is, if you like, a sort of woody substance that makes them stiff. That combination of generative and skeletal hyphae is what's seen in most of the bracket fungi, those that need to support themselves with some sort of skeletal structure. And the skeletal hyphae, of course, arise from the generative hyphae. You need that when you need to have a bit of grunt, as it were. There is, however, a third type of hypha, and we can have a look at that in this example, rather complicated example here. We've got simple hyphae. There's one running across the top here, thin wall, generative form. This one has got a branch on it. It's got a little clamp connection up there. We've then got the skeletal hyphae, like this one running down here, and this one running across here, with thick walls, virtually no lumen, dead, and impregnated with fungal chitin to make them stiff. But the third type are these strange looking wiggly branched jobs here. And these are what are called binding hyphae. And they are seen in the very tough, woody forms of bracket, and they have the effect of literally binding everything else together and making the whole thing really solid. Back in the 1930s, I think it was 1932, a guy called E.J.H. Corner, a mycologist, coined terms for these kind of three stages of structure. He called those with just one type, in other words the generative hyphae, monomitic, those with two types of hyphae, dimitic or dimitic, and those with all three types, trimitic. And if you look in one of the typical heavyweight books like this one, B&K Volume 2, you'll see that each set of notes includes whether they are monomitic, dimitic or trimitic. So it's a form of classification which is quite useful. I ought to say that there is one oddity which you are quite likely to come across, and that is chicken of the woods, Lettiporus sulphureus. Most dimitic fungi have generative and skeletal hyphae, but chicken of the woods has generative hyphae and binding hyphae. It has no skeletal hyphae at all, so it's a bit of an oddity. This is growing on what was oak and is okay if you are one of those people who is not allergic to it. However, 1 in 10 people is violently allergic, and I mean violently. I've seen it happen. It is not pleasant. But there is another caveat. This grows on a number of host trees, one of which is yew. And if it grows on yew, it will absorb the toxins, the taxine from the yew, and it will possibly kill you if you eat it. So you need to bear in mind what it's growing on. We're not particularly talking about edible species in this program, but it is worth mentioning this one. And it's one of those that comes out very early in the season. It's actually 2 days short of Midsummer's Day at the moment, so you need to start looking for this pretty early.
White skins on dead wood are generally constructed with generative hyphae only. They have no need to support themselves. Some, like Terrana carolea, can develop little embryonic ledges, but they remain monomytic. At the other end of the construction array, a woody lenzites on birch is clearly trimitic. So are all the Ganodermas, including this one, Ganoderma resinaceum. The addition of the binding hyphae allows them to grow pretty large. Some, however, don't conform to what you might expect. Schizopora paradoxa is common, and you might expect it to be monomytic, but it actually contains skeletal hyphae and is dimitic.